Dear all, welcome to Civil Services with ZAKI. First of all, very happy Diwali and wishes of the happy Diwali and the festival of light. So let's start with today's topic. So today's topic is what causes hill, and it is related to the major geographical concept series. As you know, our concept series is based on best graphics, best animation and all that. So today's we will discuss about the what causes hill, and in this lecture we will discuss various questions regarding the formation of the hill and various processes. So see what are these topics. So number one, what causes hill? Second is how does hill form? And third one is what are updraft and what are the Bergeron process. So what is Bergeron process? And another is what is downdraft and what control the size of individual chunk of the hill. So we discuss all these topics, so you stay with us till the end of this video. So first we start with what causes hill. So as you know, hill is a ball of ice that form under the freezing temperature within the cumulonimbus cloud, and that subsequently fall towards the surface. Large hail that reaches the surface can do so at high enough speed and with enough force to smash windows and dent car and destroy entire field of the crop. So these hills are very dangerous for the crop field. So how does hill form? What control the size of individual chunk of the hill, and where and when is hill most common? So we will discuss all these topics in today's lecture. So let's start and see how does hill form. So if you see, most of hill form in association with the supercell thunderstorm. So basically it is associated with supercell thunderstorm and much less commonly with the other type of the thunderstorm. So supercell thunderstorm basically related to the cumulonimbus cloud, and it is very high vertical clouds like this. So this cloud go beyond the troposphere and from the much of the more parts of the stratosphere. So it is sometimes it is 30 kilometer or more than 30 kilometer high, this type of the supercell. So what is supercell thunderstorm, what is single cell thunderstorm, and what is the multi-cell thunderstorm? If you want to know more about all that, then you can join our regular lecture, and our regular lecture correctly running in various coachings in Delhi and NCR. So we can see now we examine how the following figure. So see this figure is the cumulonimbus cloud. So examine this figure and try to understand the formation of the hill step by step. So see how these hill form, so we can try to understand these formation of the hill step by step. So see the first step. So first step is related to very strong updraft. So supercell thunderstorm and other strong cumulonimbus cloud have a strong updraft. So these areas, so updraft means uplifting of the air current. So what is air current and what is wind, etc. So you can join our class for all that. So strong updraft capable of lifting raindrop, chunk of ice, and even the plane. So if imagine some aeroplane can enter in this area, they can also uplift the aeroplane. So strong this type of the updraft. So updraft is the here supercell updraft is very strong. So see the second stage. In second stage, we once air rises high, so these air rises near the high, and so the freezing line, so this is the freezing line. So if you go above the freezing line, it is minus degree Celsius, and if you go below the freezing line, it is plus degree Celsius. So here temperature is negative and here temperature is positive. So once air rises high enough that it enters the sub-freezing parts of the cumulonimbus cloud, so above the red line, so the Bergeron process causes water vapor. So here the Bergeron process denoted with the V, this type of the Bergeron process, it means the super cooled or the freezed nucleus of the ice added with the more and more chunk of the ice in etc. It is called the Bergeron process. So Bergeron process is the deposit into the ice particle into the small droplets of the a small chunk of the one ice into the, so it means if you see super cooled this, so some of the this particle added with this particle added, so this is gradually increasing. So that's like the collisions, as you know, our previous video, what is precipitation. So if you want to know more about the precipitation and all that, and all the collisions, like that collisions, this type of the Bergeron process also happened. So if you want to know more about this, so you can watch my previous video. So causing it to grow, so resulting hail began, so more or less spherical. So resulting here above the freezing line, so it is a small droplets and more or less spherical. So after that they uplifted by the above in the central part. So see the another step. So another step, as the central parts of the storm continue to rise, more vapor deposited occur in the hailstone become larger. So here deposited and hailstone become the larger due to the Bergeron process. Bergeron process continue happen in this situation. So it's become larger, so the hailstone will be continue rising as long as it's too heavy to lifted by updraft. So here it's very heavy. They cannot lift it by updraft. Now then they go to the nearby downdraft. So see the next step, and the next step is the eventually the hailstone become influenced by the nearby downdraft. So here, so see a nearby downdraft, so it is so big, so they can influenced by the nearby downdraft. Nearby downdraft. So beginning downdraft and arcing follow path. So these are type of the follow path, and they came into the this type of the, and finally they reach to the below the freezing point. So see the next step. So next step, if the downdraft causes the hailstone be carried below the freezing height, the outer surface of the ice partially melts. So they go to here and they partially melt, and all at this stage all core of the ice coated with the layer of the liquid water. So here then here this ice coated with the liquid water. So it is covered by one layer. So if see this is the ice and this is coated with the liquid water. So while temperature are above freezing, so more liquid coated here. So here go to the, so more liquid water water deposited in the chunk of the ice. But eventually it can be before hailstone can fall to the ground, it might get to the another updraft. So it might go to the another updraft, and after that updraft, this the hailstone above the freezing height, so they go to updraft and they finally reach again in the freezing point. It means the above the this red line, so above this red line is a freezing point. So the coating liquid water, most of which was probably melted ice and can refreeze. So these coated water on this new layer, they can refreeze, and finally they go to the second downdraft. So once again the developing hailstone gets caught in the downdraft, so they go finally the second downdraft. After falling to the warmer part of the cloud below the red line, more melting occurs. So they go finally this area, and more ice melting and more water accumulated here the nucleus of this ice. So this process, if you see this process, this cycle or this process repeat many times, one times, two times, three times, and all that. So freezing and deposition, once go to the above, freezing, go to the below, it means melting. So melting, freezing, so all that happen, and due to the Bergeronian process, once the hailstone go to the so large, so each trip down result in the another layer of the ice added in hailstone. Eventually the developing hailstone become too heavy, so it's go too heavy and be lift and to be lifted, so become to be heavy to be lifted by the updraft. So they hailstone, no, they're so heavy they cannot lifted by these updraft. So and gravity finally pull to the surface and finally go to the surface, and this is called hailstone. So see, examine this picture. So see, this is one cycle, two cycles, three cycles. It means 1, 2, 3 and 4 cycles. So if you see this part of the hailstone, it's basically happened in the 4 cycles. So it may be 4 cycles, 3 cycles, 2 cycles, 5 cycles, and many more cycles. So that's why this type of the hailstone needed more supercell cloud and cumulonimbus cloud. Basically it is the vertical type of the clouds. So if you want to know more about what is cloud and etc, then you must subscribe our channel, because our video on cloud will be coming in the next few weeks. So see, another thing is the what factor influence the process of the formation of the hail. So for example, a number of factors influence the process of the formation of the hail. For example, if you see the freezing level is higher in the summer and lower in the winter. So if you see freezing layer, so winter, if you find freezing layer here, in summer you find freezing layer here. So they can change in the summer and the winter. Hail formation most likely the time of the year when the cloud extend subsequently both above and below the freezing point. So you need such type of the cloud, they form above and below the freezing point. So subsequently, so if the cloud entirely warm on freezing zone, so if so see here, if cloud only, so see it is freezing line. So if cloud form only here, it means only rain. So on, and if cloud form this layer, it means only the snowfall and etc. So if it could entirely warm, then freezing it will be produce rain. If the entire cloud below the freezing temperature, it will be produce snow. So other important factor is the, so another important factor is the moisture content. So moisture, vertical extent of the cloud, and strength of the updraft and downdraft. So updraft is more strong, it means more, you can find more layer on the hailstone. So updraft and downdraft. So and the temperature contrast between the air masses across the front. So temperature contrast also play a mega role in these the air masses. And air masses, what is air mass? You can see my previous video on air mass. And what is front? You can see my previous video on what is fronts. So what are fronts and air masses and all that? So you can find this video in our channel. So thanks for watching this video, and once again happy Diwali to all of you. Thanks a lot.